which involved order. So if you had two letters, you know you could permutate them two ways. In lining up, for example permutations, lining up students, setting up a batting order, hanging pictures on the wall, order is significant. There are problems where order is not significant. So if we have the letters A and B, we're happy. We don't care what order they're in, right? But here, permutations, we care about order. Here, the count is 2. Here, the count is 1, right? If you're just working with data. There are problems where order is not important. Choosing members of a committee or picking books off a shelf. The order is not of interest. Problem where order is not important is related to an area of math which is known as set theory. Okay. A set is a collection of distinct objects. Sets are denoted by uppercase letters. So for example, we might say, okay, A is the set of prime numbers less than 10. So that would be 2, 3, 5, and 7, right? So we might give it the name A, capital A, or capital B, or capital Z. It doesn't matter. So this is an example of prime numbers less than 10, 2, 3, 5, 7. Elements or members are objects in a set. When elements are listed, they are included in brace brackets, like this, like I did up here. Just do your best. It takes some getting used to draw brace brackets. Okay, but you can do it. And the elements or members are separated by commas. So 2, 3, 5, 7. The number of elements in a set is denoted by NA. So for example, the number of elements in set A would be 4. Right, there's 4. 1, 2, 3, 4. For example, if Z is a set of fruits and we have Z equals banana, pear, apple, kiwi, the number in Z equals 1, 2, 3, 4. If B is the empty set, the empty set can be denoted like this, okay? Empty set. The number in B is 0. Let's keep going. If two sets have no elements in common, they are called disjoint sets. And we can draw a Venn diagram like this to represent it. So there's A, there's B, and S denotes the universal set. So let's say S could be all letters of the alphabet, all 26 letters of alphabet, for example. And in a disjoint set, if A equaled A, B, C, then B could equal, I don't know, X, Y, Z, whatever. But notice that these guys have nothing in common. Absolutely. So A, there's no A and B. B, there's no B and B. C, there's no C and B, etc. And there's no X, Y, Z and K. If all elements of a set B are also in set A, we say B is a subset of A. And we write it like this. B is a subset of A. We just said everything that's in B is contained in A. So for example, if B equal A, B, C, and D and A equal A, B, C, D, E, you can see that all the elements of B are in A. A is in A, B is in A, C is in A. So B is a subset of A. Have you guys seen this before?
Yeah.
Yeah.
When you break down real numbers, or rational and irrational, those are subsets of complex numbers.
Absolutely. Now, if two sets equal each other, let's say A equals A, B, C, and B equals A, B, C, you could represent it in a Venn diagram looking like this. This is where A equals B. They're identical. For a set A, the complement of A is the set denoted A naught. So, let's say S is all 26 letters of the alphabet. Alphabet. So let's say A equals A, B, C, keep it simple. Then A naught would equal everything outside of A but still in S. So this would be D, E, F, G, all the way up to X, Y, Z. Right? All the letters except for A, B, C. Okay. Am I going too fast? Yes.
Can you just explain this part again, how like A is the circle and the color around it? Is that what
Okay.
you're saying?
So what they're trying to show is A naught, everything outside of A. So in order, whatever's in A, let's say it's A, B, C. If this is A, B, C, then everything outside of A is A naught, and you'd have D, E, F, G, H, I, all the way up to X, Y, Z.
Okay, thank you.
So it's called A naught.
A naught.
The not.
It's the complement of A, or you can call it A naught. Now, the union of sets A and B is.
We're recording, but our headset's off.
I hope it worked out. Thank you. All right. For two sets A and B, the union of A and B is denoted the set A union B. So for example, if A equals A, B, C, B equals C, D, E, the union A union B is everything in both. A, B, C, D, E. Do you see something in that's the way it's denoted, like they shade what we're aiming for. This is A union B. Now, do you see if these guys have anything in common? Does A and B have C? So the next one is intersection of A and B, and A intersection is what they have in common, which is C. Mm-hmm.
So is A union B basically A plus B minus A intersect?
Yeah. Yeah, you just list them once. Everything is just listed once, yeah. Because if you just add these two together, C is counted twice, so you have to subtract C. Absolutely. What would A union B not be? Well,
It would be like the unshaded part of this.
it'd be this, but if you could, we're going to do that in the next example, so maybe if you don't mind waiting till then, and then you can get your question in. Okay, for two sets A and B, the intersection is the set denoted by, this is A intersection B, and notice they are emphasizing what they have in common. So if we were to go up here, C would be there, AB would be here, and DE would be here, like that, right? It's hard to see, right? But I will show you in the next, we're going to do a comprehensive example, and then everything will be illustrated, okay? So let's flip over. S is the set of posits, so this is your universal set. That's what they're describing. So S is going to equal 1, 2, 3, 4, 5, 6, 7, 8, 9, right? These are positive integers less than 10. A is equal to 4, 5, 6, 7, 8. B is the set of prime numbers. Always remember the lowest prime number is 2. 1 is not considered prime by definition. So this is 2, 3, 5, and 7. There's 4 prime numbers less than 10. Find the following and draw the corresponding Venn diagram. So you might want a pencil. So A naught is everything outside of A. So this is 4, 5, 6, 7, 8. So A naught will be everything outside of A but in S. So it's 1, 2, 3, and 9. So let's give it a draw, won't we? So we'll draw the Venn diagram. You have to draw the box. Some people don't like drawing boxes, but you have to, because you have to denote the universal set. So here we'll have A, and in A we have 4, 5, 6, 7, 8, and A naught will be 1, 2, 3, 9. And this is our universal set. Don't forget to put S for universal set. And we're emphasizing A naught so we can shade A naught. Now they want B naught. Okay, so this is A naught. Let's do B naught. So here's B. B is 2, 3, 5, 7, and B naught would be 1, 2, 3, 4, 6, 8, 9. 1, 4, 6, 8, 9. And because we're emphasizing B naught, we can shade outside of B. And this is B naught. A union B. Do A and B have anything in common? Because if they do, we're going to have to draw overlapping circles. So it looks like A and B have 7 in common. Oh, 5 and 7. So that's common to both, so we can draw it just like that. So in A we have 4, 6, 8. This is A. We'll call this B. In B we have another 2 and a 3. So this is A union B. And then outside A union B we have 1, 3, 4, 5, 6, and 9. And because we're emphasizing A union B, we shade the 2. A intersection B will look a lot like C, but just different shading. Two, 3. This is S, 1, 9, and A intersection B is right there. Sorry, I haven't been writing the answers. B naught is 1, 4, 6, 8, 9. A union B is 2, 3. I'll drink to that. A intersection B is 5, 7. Yeah. So far, so good? Okay. Uh-oh. A naught union B naught. Well, we're going to use these two guys to help us. That's going to equal A naught union B naught is going to be, well, let's draw this. A naught, well, this is going to be interesting. Well, let's just see. Let's draw it first. Well, let's draw it. It'll look like this. We're just going to shade, okay? A naught union B naught. Yeah, how'd you get that so fast? A naught union B naught.
Should you write all the A naught inside?
Are we supposed to put the A naught and the B naught together? How do you, like, 1, 2, 3, 4, 5, 6?
Yeah, that's what I said.
That was A and B together.
Okay, so it'll be 1, 2, 3, 4, right?
Why one?
Isn't there a 1 in B naught?
It's A naught plus B naught. That's the union. And that's basically the question A and B.
6, 8, 9. So I want to show you how to draw that. That is going to be, you're absolutely 1, 9 is out there, right? And this is 2, 3, A, B. Okay, so this is how you draw it. Everything outside of A, so that's everything outside of A. Huh? Sorry. Yeah, everything outside of A. And now everything outside of B. So it's everything but 5 and 7. Right? Everything outside of A with everything outside of B. Okay, let's do A naught intersection B naught. What did they have in common? 1, 1, and 9, right? That's the only thing they have in common, right? So, A, B. So this is 5, 7, 2, 3, 4, 6, 8, 1, 9. So we're just shading everything outside of
Is A naught its own set?
yeah.
So if A naught and B naught is its own set, no, then it wouldn't work with the Venn diagram. Never mind.
Okay. Okay. A union B naught. This is A naught intersection B naught. You should label it. just get the basics down here. A union B naught is going to be 1 and 9, right? Because everything outside of A union B, it's just 1 and 9. So it's 1, 9. This is 5, 7, 2, 3, 4, 6, 8. And we're just going to shade the outside. Now, do you notice that there's some things that are the same? So note A naught intersection B naught is equal to A union B naught. They're equal.
Can you do it like this instead? The set of, because what you're trying to find is the intersection of A naught and Z naught. So when you do that, can you do it like this? Or
I get a different answer though. Can you see my answer's different from yours?
but that's because you're using the set A and B. I'm using the set A naught and B naught.
Oh,
So does that work, or is that wrong?
I've never seen it that way, so maybe just for now, just stick to this. That's one I've never seen. That's very interesting. Okay. I don't see anything wrong with
That's
it.
why I asked if A naught and B naught is its own set, because if it is, A naught should exist within the set of universal numbers.
Yeah, that's interesting.
That's how I think. That's just how I saw it when I first did it.
Yeah. That's interesting observation. Thank you for that. I've never seen it like that, so I can't be sure. S A intersection B naught. So where's our A intersection B? Right there? Okay. So outside the intersection, so all of this would be shaded except for the intersection. So notice some of these are equivalent. So A naught union B naught is equal to A intersection B naught. Because these two guys are the same, right? These two guys are the same. These two guys are the same. I think there's a homework question like that. Can I elaborate on anything or explain, give fuller details, anything you want to know? Narayan, was your question answered? You could be easy marks. Are we good?